Okay, this is lesson 6-7, volume of pyramids and cones. It's in page 312 of your book. First of all, let's take a look at the three diagrams I have at the top. There are two different pyramids. So the first one is a rectangular based pyramid, and that means the base that's colored here in light red is a rectangle shape. The second one is a triangular pyramid, and the base on this one is a triangle. And finally, we have a cone, and the cone has a base that is a circle. Okay, so let's take a look at these three. When I have any kind of pyramid and or cone, I have a basic formula that says the volume is 1/3 the base times the height. In this case, the base is this blue B right here. I'm going to underline it here. This blue B is the area of the base. So the base of my rectangular pyramid would be the rectangle, like that. The base of the triangular pyramid is this triangle, and the base of the circle is the circle, or the cone is the circle. So when we talk about the blue B value right here, you calculate the area of the base, you multiply it times the height, and you can see right here that I've highlighted the three different heights of the pyramid. And the height of the pyramid is measured from the point of the pyramid and or cone, and make a perpendicular line down to the base, and that is the height of your cone or pyramid. So you take that area of the base, multiply it times the height of your pyramid or cone, and you still have to multiply it times 1/3. So writing these out directly, the area of the base of a rectangular pyramid, right here, area is equal to base times height, the base of the square at the bottom, a rectangle at the bottom, and you can see that in blue I wrote that in down here, that is what's in blue. For a triangular pyramid, we have the area of a triangle is equal to 1/2 base times height, and you can see that we substituted that in the formula. And for a cone, we have a circle, and the area of a circle is pi r squared, and we substituted that in down here. When we multiplied each one times the height of our pyramid in the first two cases, of our cone in the third case. So, only thing that changes is how you calculate the area of your base. And you go find the shape of the base of your pyramid or cone, and then you calculate its area, and then you plug that into the formula, 1/3 times the area of your base times the height of your pyramid or cone. So here's an example. Find the volume of each, A, B, and C. Let's take a look at A first. We have a rectangle base. Looks like that, and it's 8 by 10. So if we look at that, 8 by 10, and that's these two numbers right here, which gives us our 80 units squared, because that's an area. Then we have a height of 15, and that goes here, which is substituted in for the h of the height. So that goes right there. And when you multiply 1/3 times 15, you get 5. 5 times 80, it gives you 400 units cubed. If I were to do that all in one formula and not do it in two steps, this being step one, this being step one, and this being step two, if I were to do it all in one step, you would see it right here. I would just take the 1/3 times the area of my base, which is the 8 times 10, times the height of my pyramid, which is 15. and I come up with the same answer as I got up above. Same answer as this line right here. Okay, now let's try the second one, B. Well, we have the same formula. The only difference is how we're going to calculate B. I'm going to get rid of that and make sure that that's color-coded correctly. B, okay, so this case, we have a triangle. The area of a triangle is 1/2 base times height. There's my 1/2. There's the base of my triangle, 3, and the height of my triangle, 8. So 1/2, 3 times 8, which is just basically 12, which we have right there. The height of my pyramid is right there, and I substitute that in, and then I multiply the 1/3 times 12 times 8, and I get 32 units. And once again, if I did it all in one step, I would basically be taking the stuff that I calculated here for B and putting it directly in the formula, and you can see it right here. Other than that, it's the same exact formula. I've got my 1/3, and then times the blue base of my triangle there, 1/2 base times height of the triangle, and then times the 8, which is the height of my pyramid. Comes up with the same answer, 32 units cubed. And then let's do the cone. Item C. Here we have the same formula, 1/3 area of my base times the height. And when we do this, we see that the base now, when you calculate this base, it is pi r squared for the area of a circle. Well, r is 2, so 2 squared is 4. So basically, I end up with 4 squared as my area of my base. It's not 4 squared, 4 times pi. So I plug it into the original formula. 1/3 times the area of my base is 1/3 times 4 pi times 12, which is the height. I got that from up there. And that gives me 16 pi, or 50.3 units cubed. And once again, on the bottom here, I just multiply it all at once. 1/3 times the area of my base, which is pi 2 squared, which is 4 pi times 12, gives me 16 pi, or 50.3 units cubed. Let's explore now the effects of changing the dimensions of a cone. If you remember yesterday that when we talked about changing the height of a cylinder, that if you doubled the height, you would double the volume. And that made a lot of sense, because if you just took a soda can and stacked another soda can on it, you could obviously see that that's twice the volume. You have the volume of 2 soda cans. But if I take the radius and double it, the radius makes it's like I have almost 4 cans of pop when I double the radius. And so doubling the height of a cylinder doubles the volume, but doubling the radius of a cylinder quadruples the volume. So let's see if that same thing holds true. So we're going to do 2 problems, or 3 problems here. We're going to have our original cone, which has a radius of 7 and a height of 14. So we give it 7 squared. Pi times 7 is our area of our base, times the height of our cone, 14, all times 1/3. So we end up with 1/3 pi times 49 times 14, and that ends up with 228.7 pi units cubed. So now we're going to double the height. In this one, you can see that our height is now 28, but our radius is still 7. So we still have our 7 squared in our radius times pi for the area of that circle. We still multiply it times 1/3 because that's part of the volume, but this time instead of using 14, we used the height of 28. And when we multiply that out, 1/3 times pi times 49 times 28, we end up with 400 157.3 pi units squared, which is basically double the size. So just like in a cylinder, if we double the height of a cone, we have doubled the volume of that cone. Now let's take a look if we double the radius. Well, doubling the radius, as you can see, we still have 14 is our original height, okay? But this time, instead of 7 for our radius, we've doubled it to 14. So now we have 14 squared in our formula, pi times 14 squared, all times the 1/3, and then the height of our cone is still 14. When you multiply that out, you get that 14 times 14 is 196. You multiply it all the way out, and we end up with 914.7 pi units squared, which is a quadrupling, or a 4x increase in the volume of a cone when you double the radius. So just like in a cylinder, doubling the height doubles the volume. Doubling the radius quadruples, or a factor of 4 enlarges the volume. All right, one example that's right out of the book, the Great Pyramid of Giza is a square-based pyramid. It's 756 feet on every side, and it is 481 feet tall. It says find the volume of the Great Pyramid of Giza. Okay, well, we know our formula is 1/2 times the base area of the base times the height. Well, the area of the base, it's a square, remember, it comes from our given, and each side is 756 long. So 756 times 756, right there, times the height of our pyramid, 481, times 1/3, and we get this large number, 91,636,272 feet squared. And just to make that a little bit visible in your mind, imagine a volleyball encased in a box that you buy from the store. That box for that volleyball is about 1 foot by 1 foot by 1 foot, or 1 cubic foot. So imagine the Great Pyramid can hold 91,636,272 volleyballs in their boxes. That's a lot. All right, now we're just going to do 3 examples, and then we'll call it quits for the day. First of all 3 of these are examples we have. We have a rectangular base, and there's the volume equals 1/3 base times height, capital B, which is the base of the area of my base. And that's the same formula for all 3 of them. All I have to do is calculate the capital B value differently. So I'm going to do that in blue. Okay? So for the problem A with our rectangular based pyramid, we know that the base is 3 times 4. And then we know the height is 5. So I'm not even going to calculate it out. I'll do that at the end. We'll go to B now. With the triangular based pyramid, we know that a triangle is 1/2 base. Well, our base here is 4 times 7. And then the height on this guy is 6. And finally, on the cone, we know that the area of the circle is pi r squared. R is 3 squared times the height, which is 10 inches. And now we multiply those all out. 1/3 times 3 is just 1. So we end up with 4 times 5, which is 20 meters cubed. Over here, we end up with 1/3 times 1/2. That's 1/6 times 6 is 1. So all we're left with is 2 times 8. So we end up with 28 centimeters cubed. And finally, on the cone, we end up with, I'll write this out, 1/3 times 9 pi times 10. And if we multiply that out, 1/3 times 9 is 3. 3 times 10 is 30. We end up with 30 pi inches cubed. And those would be our three answers to those problems. And that's today's lesson.